And then we have question 12. Now this is actually an O exam question. I think it was a multiple choice question though, but I've removed the options. So we're just gonna find it, and I honestly think it wouldn't matter that much. Obviously, if you have a multiple choice question, you can submit an answer regardless, but hopefully we can do this question from scratch. Just start reading it. Okay, airbags are an important safety feature of today's cars, and it contains a mixture of solid sodium azide, okay, and potassium nitrate. Not sure where this is going. In the event of an accident, trip sensors send an electric signal to the igniter. The heat generated causes the reactants to decompose completely according to the following equation. I think that's supposed to be a bracket, so I'm going to fix that. Okay, a particular car's airbag was found to inflate to a volume of 62. I'm going to fix it now because this is annoying me. Anyway, you have a cab something or other. Found to inflate to a volume of 62 liter. I think the first thing I'm going to point out, and hopefully we know how airbags work, is it's going to this decomposition reaction is going to produce a gas, which is nitrogen, and this is the only product in this reaction that is actually in gas form. So the increase in volume and the puffing of the airbag is solely due to the production of this nitrogen gas. Okay, a particular car's airbag was found to inflate to a volume of 62 liter at a pressure of 100 kilopascal when the temperature reaches 36.6 Celsius degree. The molar mass of sodium nitrate azide, you will, is 65 grams per mole. What was the mass contained in the car's airbag, the mass of sodium azide? Not a hard question actually, but I think the most important thing is to actually be able to notice the states of the reactants and products and associate this volume and this pressure and this temperature with nitrogen, which is a gas, so you can use the universal gas law. So question asks for the mass of NaN3. They have very kindly given you the molar mass of NaN3, which is 65 grams per mole. That's supposed to be per. Okay, now you should. So one of the product is N2, which is a gas, which means I'm allowed to use PV equal to nRT. And I think the increase in volume of 62.0 liter, as well as the increase in pressure, actually not really. The increase in volume is solely due to the production of this gas, because all the other substances are solid, so I think it's safe to assume that they won't contribute too much to the volume of the airbag. And temperature is 36.6, that's not 6 Celsius degree. So I think what I'm going to do, I'm going to assume a complete reaction, because the question asks for the mass of the reactant, and you've given some physical quantities measuring the amount of product. So I'm going to assume that if I can find the number of mole of nitrogen gas, I should be able to use mole ratio to determine the number of mole of sodium azide, and then find the mass of sodium azide. Azide? I don't even know how to pronounce that properly. However, I'm going to convert that to Kelvin because I think I'm going to use the universal gas equation to determine the number of mole of nitrogen gas in this case. So 309.6 Kelvin. All right, we don't have enough room, so step 1 is to find number of mole of nitrogen. So if we have PV equal to nRT, in that case, number of mole will be PV over RT. So 100 kilopascal, can't remember what that is, 62 liter, 8.31 is the universal gas constant. Temperature in Kelvin is 309.6, so the number of mole is going to be, if you think about it, this is quite a bit of work for a multiple choice question, but you're going to find those in the exam, especially when it comes to gases. I think they tend to be fairly difficult and highly, the wording tends to be very unusual. Okay, I need to find the number of mole of NiN3, so it is my unknown. I already have the number of mole of nitrogen, so that's my given. You form the ratio in the form of unknown over given. It makes it a little bit easier to transpose, but you obviously don't have to. Now this is a 10 to 16 mole ratio. You don't have to simplify it, but it is fine with it. But anyhow, let's just leave it like that. It's fine. I rather you leave it like that than try to simplify incorrectly and then stuff up all of your hard work, even though the unsimplified fraction just annoys me. But anyway, so times 10 over 16. It'd be very funny if it's not. I think it is 10 over 16. Yeah. So 1.506 something or other mole. Once again, this is in reality a multiple choice question, so all this working out doesn't count. But you really want to keep the exact values in your calculator, just in case they decide to give you two options that are only off by a little bit. So the molar mass they have very kindly provided to you is 65, because otherwise you haven't done enough steps as it is. So I get 97.9. I don't treat this as a multiple choice, and as a short answer, I think I'm going with three significant figures based on everything given to me is in 3 sig fig. So this is my answer, 2 3 sig fig. And we are done. I think this question is easier than I remember. Maybe I was thinking of another question. But anyway, that's it. Let's just stop this video, and that is the end of this worksheet.